Hello everyone, today's topic is transformation and its properties. First of all, definition of transformations. Transformations are changes done in the shapes on a coordinate plane by rotation, reflection, or translation. What are transformations in math? A function that maps to itself is called the transformation. The pre-image x becomes the image x after the transformation. This transformation can be any or the combination of operations like symmetries, parallel translation, reflection, rotation. Rules for transformations. Consider a function f at x. On a coordinate grid, we use the x-axis and the y-axis to measure the movement. Here are the rules for transformations of functions that could be applied to the graphs of functions. Transformations can be represented algebraically and graphically. As just said, symmetry repeats the first phase to the second phase. The same is the case with human actions. As the intention of a person is, the result will be according to it. First, transformation of symmetries. Central symmetry does not change the distance between corresponding points. The transformation that transfers each point in the plane to a point symmetrical about a certain center O is called centrally symmetric equations. If we move any point of the figure F to symmetrical points relative to the center O, then in general another figure F1 is obtained. The figures F and F1 are called symmetrical figures about the center O. Second, transformation of parallel translation. The parallel move transformation moves points along parallel lines by equal distances in the same direction without changing their distances. Let's set the points A1, x plus a and y plus b, corresponding to the point A, x, and y. In the Cartesian coordinate system in the plane, here and a and b are constant numbers. Such a transformation in the plane is called parallel copying. So, during parallel copying, if the point A, x, and y moves to the point A, x1, and y1, the equivalence x1 equals to x plus y and y1 equals to y plus b are fulfilled. Third, transformation of reflection. Reflection is a mirror image of the function. When the points are reflected over a line, the image is at the same distance from the line as the pre-image, but on the other sides of the line. Every point P and Q is reflected onto an image point Q and P. If point A is 3 units away from the line of reflection to the right of the line, then point A1 will be 3 units away from the line of reflection to the left of the line. Thus, the line of reflection acts as a perpendicular bisector between the corresponding points of the image and the pre-image. Here is a graph of a cubic function that shows the transformation of reflection. The function f at x equals to x cubed. The transformation of f at x is f at x equals to minus x cubed. That is the reflection of the f at x about the x-axis. First, transformation of rotation. Rotation is spinning the function about a point. The shape rotates counterclockwise when the number of degrees is positive and rotates clockwise when the number of degrees is negative. The general rule of transformation of rotation about the origin is as follows. To rotate 90 degrees, x and y maps to minus y and x. To rotate 180 degrees, x and y maps to minus x and minus y. To rotate 270 degrees, x and y maps to y and minus x. In the function graph below, we observe the transformation of rotation, wherein the pre-image is rotated to 180 degrees at the center of rotation at 0 and 1. Let us observe the rule of rotation being applied here from x and y to each vertex. The transformation that is taking place here is from x and y maps to minus x and 2 minus y, and minus 2 and 4 maps to 2 and minus 2. So minus 3 and 1 maps to 3 and 1, and 0 and 1 maps to 0 and 1. Example 1. How can make describe this translation algebraically? Solution. Let the orange triangle be the pre-image and the blue triangle be the transformed image. Represent it on the coordinate plane as x and y. Comparing the relative positions of their triangles, we can observe that the blue triangle is placed on position down and 5 positions right. So answer this transition is expressed algebraically as x and y maps to x plus 5 and y minus 1. So example 2, a point A 1 and 3 is translated 4 units to the right. What are the coordinates of the transformed image? Okay, solution. A maps to A1 equals to 1, and 3 maps to 1 plus 4 and 3. So A maps to A1 equals to 1 and 3 maps to 5 and 3. So answer the coordinates of the transformed image 5 and 3. Okay, example 3. What do the following transformations do to the graph? F at x maps to f at x minus 2, and f at x maps to f at x minus 2. So solution, f at x maps to f at x minus 2. The y coordinate undergoes the change. Thus, the transformation here is translation 2 units down. F at x maps to f at x minus 2. The x coordinate undergoes the change. Thus, the transformation here is translation 2 units right. Okay, answer first translation is 2 units down, and second translation is 2 units right.
Okay, now let's practice. I hope this video was useful. Thank you for your attention. Thank you. Goodbye.